So, hello everyone. My name is Seung-Yeol Baek, Professor Seung-Yeol Baek, and I will proceed this computer vision class during this semester. So, for today, I will briefly introduce what we will learn during this course for one semester. Okay. So, this is a computer vision course, actually advanced computer vision for CSE. For 545, our class name is Advanced Computer Vision. Actually, this course is a computer vision class for the graduate student. Okay. And I'm Professor Seung-Yeol Baek, affiliated to AI Graduate School, and also I'm partially affiliated to CSE department. And this course, the goal is to understand what is computer vision and deep learning algorithms. And also we have to understand how to implement image video processing algorithms in using the Python and their OpenCV and PyTorch library. So are you guys familiar with OpenCV and PyTorch? No? Okay. Uh, I mean, are you AI graduate? Most of you, as far as I understand, most of you are AIGS student, right? So please raise your hand if you are not AIGS student. Okay, so you are coming from CSE. Okay, so is there any student coming from department other than AIGS and CSE here? So where are you from? Chemical engineering. Okay, so have you used any deep learning before?
I have studied about theorem of learning.
Theorem?
Young girls learning
Uh, okay.
MLP or CLM.
Mm.
And
Have you implemented that before?
well,
Okay, just okay. Study some theory. Okay, okay. Anyways, we will make you understand those algorithms again during this course, and also help you to learn how to implement those algorithms using the Python and their library, OpenCV and PyTorch. Okay. So actually, OpenCV is the open library for implementing the image and video processing algorithms. So their interface is actually very easy. So you will become to know about that. And also PyTorch, this is the library that can help you to implement the deep learning algorithms easily in the Python. Okay. So we will learn about that. Okay. So before midterm, we will learn about basic machine learning and deep learning algorithms. Okay. And also, I will teach you how to implement those algorithms using the OpenCV and PyTorch library. Okay. And after midterm, we will do final term project. Okay. Uh, okay. I will explain what is final term project after this. Okay, so grading is we will assign two assignment, programming assignment spanning this course. Maybe around midterm period, we will provide one assignment, programming assignment, and after maybe before final term, we will notice another assignment. There will be two assignment during this course, and that will count for 40% of your overall score. Okay, so in syllabus there it was 45%, but it will be 40%. Okay? We increase the importance of the final term presentation rather than PA. Okay, so 5% is becoming different, and there will be two quiz. So there is no midterm or final term exams, but instead we have two quiz during the course. Okay. So right before midterm, right before final term week, we will take two quiz. Okay. And first quiz will be about general deep learning, and machine learning and computer vision things. Okay, and second one will be more about the computer vision algorithms, transformer or some other architectures. Okay, and I will notice you before 1 week before the quiz. Okay, and that will count for 30% of the entire score. Okay. And we will also do the final term presentation, and that will count for 30%. And this is actually the team project. Okay, maybe I'm expecting we can gather 3 team members together. Okay, and not 25%. Sorry, this is 30%. Okay. Okay. So will be 2 or 3 team members. Okay, and there will be 2 presentations for each team. So you have to pick and present a top tier paper, one top tier paper. You have to pick, and that paper have to deal with some visual recognition tasks because our class is computer vision. So the paper, their topic have to be related to object detection, segmentation, or pose estimation. Okay. And the method have to use VLM, transformer, or more recent architectures. Okay. And also, the code for that paper have to be publicly available. Okay. Unless you can choose the paper whose code is not available, but you have to implement that in that case. Okay. So in the final term project, we are not enforcing you to implement the paper, but we are wanting to make you first understand the paper, and also then present it. And then the second round, we want you to conduct more evaluation studies using their code, okay? And understand their strengths, their algorithms' strengths and weaknesses, okay, in depth, okay? And then after doing this kind of analysis, you have to present these strengths, weakness, or evaluation studies or characteristics of their algorithms, okay, in the second round presentation, okay? So, and also you have to submit additional final report summarizing everything, okay? So this is the final term presentation, okay? Okay. So you don't have to implement everything, but you have to do that if there's no code. So we recommend you to select a paper whose code is available in the GitHub or other venue, okay? And then using their code, you can do more analysis and evaluation studies, okay? And use that for your presentation and also the final report, okay? Okay. And in final term project, the first round presentation will count for 30% of overall score, and second round presentation will count for 50% of the overall score, and final report will count for 20% of overall score. Okay. So second round presentation will be the part that counts for most of the overall score. Okay. And first round, you have to present what is the paper is doing. Okay. So we will evaluate you based on the level of understanding about the paper in the first round. And in the second round, you have to do some analysis and do some more evaluation studies and present that, okay? And we will evaluate you based on the suitability of the evaluation studies that you conducted and further analysis for, understanding the characteristics of the algorithm and paper. And also we will evaluate you based on the team collaboration, okay? And then final report will be similar to their evaluation criteria is similar to the second round presentation. Okay. Okay, any questions till now? Okay. And there will be a late policy. So for every assignment, but not for final term project. Uh, for the 2 programming assignment, we are giving you 1 free late delay day. Okay, so you can freely delay the programming assignment, their submissions by 1 day. Okay, and after 1 day, we will deduct your score by 25% for each day. Okay, this is the late policy for programming assignment. Okay, but I mean for the final project, there will be no late policy because the deadline for final term project is normally the end of the semester. So we don't have any time to give you more delay. Okay, so for processing the final grade, we have some time, and the deadline for final term project will be the latest day, I mean, before the final grade processing time. So we cannot give you more time. Okay. I mean, if you fail to meet the deadline for the final term project, then you will get 0 point. Okay. So don't miss that deadline for the final term project. But for the 2 programming assignment, we can give you 1 free late day. Okay. A free late day. Okay. And after that, we will deduct your score by 25%. This is the policy. Okay. And this might the reason for taking this course, computer vision course. Okay. So I'm thinking that most of you are I mean, having wanting to becoming the computer vision researcher or AI researcher in this academic field. Okay, so wanting to publish some papers in conferences, top AI conferences like CVPR, ICCB, ECCB, or NeurIPS, ICLR, ICML. So that's one reason. Or maybe you can be some engineer in industry as well. And also, some of you may have to take this course for mid your graduation, maybe, I mean, class credit, maybe. Yeah. Anyways, we can help you anyways to grasp more knowledges in the AI domain, okay, during this course. And I'm strongly recommend you to have proficiency in Python. If you don't have any knowledge in Python, then we cannot help you. Okay, so please seriously reconsider taking this course if you do not know Python. Okay, but if you know Python, based on that, we can help you to further learn about the computer vision library whose name is OpenCV. And also, we will may help you to further learn about deep learning library, the PyTorch. Okay. Uh, and we are not allowing to use the TensorFlow, which is another library for implementing the deep learning. But there's some issues for us. So we are not allowing to implement the programming assignment or other final term project in TensorFlow. We are not allowing that. So you have to also pick some paper for the final term project whose code is in PyTorch, okay, not TensorFlow, okay. Actually, yeah, PyTorch is the library introduced by Facebook Meta, and TensorFlow is the library introduced by Google. Okay, but uh, I'm not hating Google, but PyTorch is more, I mean, suitable for research purpose. And I think in this course, and also they are not compatible each other. So there's some problem in scoring the code. So we are encouraging you, actually forcing you to use only the PyTorch. Okay. And also to take this course, you have to have some mathematical background, linear algebra and probabilistic theory. Okay. Okay. And because you are a graduate student, I think you already are familiar with this type of things. Okay. And we will, based on that, we will further learn about machine learning and deep learning algorithms. Okay. And this is optional textbook. You don't have to buy that. Okay. So, and also their online material is already available in these links. Okay. So you can follow this link and see their materials. Okay. So to be honest, you don't, I mean, if you understand every materials from my slide, these books are not required. Okay. But if you want to study more, if you have time and if you want to study more, then I recommend you to read about these books. Okay. And you don't have to buy that books because the online link is already available. And also for the assignment and final term project, you have to have some reasonable amount of GPU resources, okay? Because this is the graduate course, we are assuming that you are having sufficient amount of GPU resources in your lab, okay? But if you don't have enough resources, then the other option might be using the Google Colab. Okay. So if you follow this link, collab.research.google.com, then the Google is providing free access to their GPU resources. Okay. And it provides 12 hours of consecutive access to GPUs freely. And after 12 hours, you have to reconnect it. Okay. But if you pay for like 10,000, I'm not sure about the exact amount, but 10,000 to 20,000 won, then as far as I know, it could be updated, but as far as I know, this limitation, 12-hour limitation is, I mean, you can break this limitation by paying that amount of money. Okay. Anyways, this is another way to bypass the limit of the GPU resources. But because this is the graduate course, we are assuming that you have at least one GPU in your local machine. Okay. And our programming assignment will be designed by assuming this. Okay. If you don't have any GPU resources, then you have to seriously reconsider taking this course because the PA, the programming assignment, will be designed by assuming you have at least one 3090 or 4090 level of GPUs in your local machine. Okay. So are you have sufficient amount of GPUs in your local machine? If not, please raise your hand. Okay, so we are actually assuming that. Okay. And this is some cheating and plagiarism policies from UNIST ECE. Okay, so you must not look at solutions that are not your own, and you must not share your solution with other students. Okay, that kind of thing. So do not copy other solutions. Okay, and also you should not use your previous work. Okay. And collaboration, during the collaboration, you also have to mention how much collaboration you have done. Okay, in the report, you have to specify this type of things. Okay, please be careful about this kind of cheating. And Q&A, because over 40 students are taking this class, so we cannot, respond to all of your email requests. Okay, so I personally highly recommend you to use the Q&A board in the Blackboard. Okay, so after this class, I will make this Q&A board. Okay, in the Blackboard. We will answer you within 48 hours. Okay, But I mean, of course, if you are thinking your issues are very emergent, then please mail me. But if not, please use this Blackboard Q&A board. Okay. Okay. So this is some policies and scoring policies and some background of this course. And please ask me if you have any questions till now. Okay. No, no questions. Then I will from now on, I will briefly introduce what we will learn during this course. Okay. So the computer vision is the how to say the field that makes some AI algorithms that mimics the human's eye. Okay. So we humans are seeing the object, okay, through our eye, right? Okay. So computer vision is the field to make maybe robot or other devices to give the ability of human eye, okay, to see some object and also understand what types of objects are in front of you or what types of actions or some pose uh, or some what types of attribute some that objects are having, what types of actions are some humans are doing. Uh, I mean, by seeing through the how to say the RGB sensors or other types of sensors, we can know. Okay, that is the computer vision field. Okay, and that have many intersections with other subjects like machine learning, graphics, algorithms, system architecture, robotics, speech, NLP, image processing, and optics. Okay, so because we are dealing with some images or videos captured from RGB camera or other types of sensors, so in that sense, we have many intersections with image processing algorithms. So image processing algorithms, we have many intersections. And also optics, definitely, because optics is the field to study about how to capture the images and video, okay, using sensors. So we have many intersections with optics and graphics as well, okay? And also most of the algorithms have to be implemented in the algorithm in the form of software. So our field, the computer vision field, is also have many intersections with algorithm and system architectures. Okay, and also as I introduced, the computer vision is responsible for making eye for the robot. So it has also many intersections with robotics, and also have many intersections with other types of sense, speech and NLP, other modality signals. Okay. And also, most of the computer vision field, their problems are framed as recognition task. Okay, so in that sense, most of problems are formulated as the machine learning problems. Okay, so this is briefly, uh, I mean, the slide briefly introducing what types of techniques are required for properly doing the computer vision research. Okay. And what is deep learning? Okay, maybe you may remember this type of event. In 2016, there was some Go match between AlphaGo and Sedol Lee, the Korean Go player. Okay, so this event was very sensational. And AlphaGo won 4 times, and Sedol Lee, he won 1 time. And actually, Sedol Lee is the professor in UNIST, right? He became the professor in UNIST. Okay. Anyways, you have to remember that AlphaGo is also the algorithm that is having the deep learning architecture. Okay. So after this event, many AI researchers and also the persons other than the AI researchers are becoming to having interest in this AI, okay, and also the deep learning. But I mean, This is the event which is very famous for even for the general person. But as a student who are studying computer vision, you have to remember this type of event, which is actually prior to that event, the Go match between Sedoli and AlphaGo in 2016. There was some ImageNet challenge from early 2010s. Okay, this is the challenge that is held using the ImageNet dataset. Have you heard about this ImageNet dataset before? Okay, please raise your hand if you heard about this ImageNet challenge or dataset. Okay, some of you already know about this. So this ImageNet dataset is the largest scale dataset that is collecting these images and their corresponding object classes. Okay, so this is the actually the labels. Okay, so there are 1,000 object classes predefined in this data set. Okay, and for each image, the humans are labeling their main object. Okay, so for example, this image will be ship image, and this image will be motor scooter image, and this image will be leopard. Okay, so among 1,000 object class, the humans are pre-labeling their object class, their main class. Okay, that is ImageNet dataset, and it has 1.2 million training data images and 100K testing data. Okay, million scale dataset. Having this type of object classes. So this was actually, proposed in 2010s, early 2010s, and was the one of the largest scale data set, okay, in that period. And actually, you have to remember these two types of event. So in 2012 and in 2015, there are two sensational events in AI domain. And in the year of 2012, these are earlier than the Go match in 2016. Okay, so in 2012, uh, they proposed the deep learning algorithm whose name is AlexNet. So here you can see AlexNet appeared, and this AlexNet is named as AlexNet. Uh, following the first author name. His name was Alex Krzyzewski. Okay, so studying in Toronto University. Okay, and this graph is showing the state of the art, the winners in the ImageNet challenge. So in each year, so this x-axis is denoting the year, and for example, in the 2010, the Lin et al. Wins the challenge. And uh, in the year of 2011, these guys are winning the challenge. Okay, and the y-axis is denoting their error rate, the winning algorithm's error rate. So in the year of 2010, the winning algorithm's error rate was 28.2%. So out of 100 images, uh, they only roam for 28 images. So are you guys following this? Okay. So, accuracy is in the opposite value. So, if you calculate 100 minus this 228.2, then that will be 71.8%. That would be the accuracy for this algorithm. Okay. And you can see the word of shallow here, okay? It means before 2012, in the year of 2010 and 2011, the winning algorithms are having the shallow learning algorithms. They are shallow learning algorithms. But after the year of 2012, the winning algorithms for ImageNet challenge was the deep learning algorithm. Deep means deep is the opposite concept to the shallow, right? So shallow learning that have just one layer. So you will become to know about what means the layer. Okay, there will be some layers in the algorithms. So, but in the shallow learning algorithm, you will see they only have one layer. So that's why they are called as shallow learning algorithm. But in the year of 2012, you can see 8 layers here. Okay. So that's why it is called as deep learning algorithm. Okay. So because they are called as deep learning algorithm because they have more than one layers. Okay. And in the year of 2012, the deep learning algorithm have the 8 layers. Okay. And you can see actually in their error rate, there are 10% gain. Okay. So in the in these years, AI researchers, maybe mostly graduate students, they reproduce other person's paper algorithms, maybe by reproducing their code, right? And if you do research in this period, improving 1 or 2% was easy. Okay, so when getting code from others, improving their algorithms by 1 or 2% is very easy. But I mean, improving them using by 10% is a hard thing. Okay, especially for large scale data set. Okay, ImageNet data set is the largest scale data set, and showing 10% gain in accuracy uh, is very hard. Okay, but and also in the year of 2011, most AI researchers are thinking that this AI field is their accuracy is somehow saturated. Okay, to bound it to this type of 25% error rate. So most people are thinking like that, but this Alex Krzyzewski and Jeffrey Hinton, they publish papers in Europe and proposing the A-layered deep learning architecture and showing 10% accuracy gain in ImageNet challenge. Okay, and this was very sensational changes in AI domain. Okay, that happened in 2012 prior to Go match in 2016. Okay, and after this event, most of the researchers are turning to use the deep learning architectures rather than using shallow learning algorithms. Okay. So shallow learning, the examples for the shallow learning algorithms are the linear regression algorithm or logistic regression algorithm or other types of shallow learning algorithms are SVM, the support vector machine or random forest, those kind of things. Okay. So deep learning architectures are, after this event, replacing all the algorithms before this deep learning. Okay, so um, especially the deep learning algorithms proposed in this Newrip's paper was called as CNN. So CNN, after this event, is prevailing in computer vision or machine learning society. And most of researches after this was changing to improving the deep learning algorithms. Okay. So you can see here 8 layers and 19 layers, 22 layers, and 152 layers. Okay. So the research trends are changing to increasing the number of layers in deep learning architectures. Okay. So researchers are finding that because it is deep learning architecture, if you increase the number of depths in layers, their performance is becoming robust. Okay, researchers are finding that trend. So subsequently, the research trends are to stack more layers in deep architectures. Okay, and in the year of 2015, the architectures who stack 152 layers appeared. And you can see their performance is becoming, their error rate is less than 4%. And actually in the rightmost column, you can see human error rate. Okay, so even humans, uh, I mean, given this ImageNet data set, because there are too many image samples, and also for some of the samples, it is even hard for humans to discriminate their object classes. So 5% of samples are wrongly predicted by the humans on average. Okay. But in the year of 2015, using the ResNet architecture, the error rate becomes less than 4%. Okay. And it means it is becoming better than human performance in image classification tasks. Okay, are you guys following this? Okay. So in red box, this is two significant event we have to remember as a AI. I mean, as a student who are studying AI, we have to remember these two events. Okay, the first CNN architecture that achieves the breakthrough in ImageNet challenge. Okay, the AlexNet architecture, and the other architecture that overcomes the human performance in ImageNet classification task. Okay, and this ResNet is proposed in Microsoft, and this Kai Ming He was the first author, and he now becomes the professor in MIT. Okay, and after that, this CNN is becoming better and better, and after 2020. The other important deep learning architecture, whose name is Transformer, has been introduced. And now most of the AI algorithms, even GPT, is using that Transformer architecture. Okay. So we will learn about this type of story during this course. Okay. And you have to, I will finish within 15 minutes. Okay. So next thing that I want to introduce you is the computer vision applications. Okay. In computer vision, there are multiple applications. For example, as I told you, similar to ImageNet dataset, the tasks that classify these images according to their main object. Okay, that is called as image classification task. Okay, and this is another data set having 10 class. And because they are having 10 class, they are called as CIFA 10 dataset. CIFA is some institute in Australia, maybe, or Canada, CIFA. Anyways, they provide this 10 class image classification dataset with name of CIFA 10. And they are having this type of 10 class, okay, and this type of images, okay. This is called as image classification. Okay. But I mean, this image classification is having strong assumption that each image is having just one main object. Okay. We always have to classify images according to their main object. But in reality, it is not the situation. Okay. So in image, we normally have multiple objects inside. Okay. So in that case, we have to specify each object's locations. Okay. And in here, we select to locate the object using the bounding box representation. And also have to specify which objects are inside that bounding boxes. Okay. And these type of applications are called as object detection task. Okay. So detecting object locations. Okay. There are many algorithms proposed for this object detection task. Okay. But this bounding box representation is not sufficient to localize the object locations because, for example, in this red box, some of the pixels in these regions, for example, are belonging to grass object rather than the car object. Okay, are you guys agree with that? Okay. So bounding box representation is not complete enough for some of the applications. So the other important application in computer vision field is segmentation task. Okay, we call this as semantic segmentation. So in semantic segmentation task, we are localizing each object using uh, bounding boxes, but having more detailed representation of pixel-wise this type of segmentation mask. Okay, so this is new representation introduced for segmentation task, and also we have their class label. We also have to predict their labels. So this is the semantic segmentation task. Okay, are you guys following this? Okay. And the other applications are pose estimation task. Okay, so pose estimation task, they are revealing the structure of how to say 3D structure or 2D structures of the given hand or human images. Or for the facial images, we also have some this type of topology structures, predefined structure. So we are wanting to reveal their structures. Okay, this is done mostly for human hand or human body or human faces because to do this type of things, we already have that kind of predefined topologies. Okay, we cannot do this for some unseen object. Okay, but for human body or human hand or human faces, there are some prior topologies because human face, we always have two eye, one nose, and one mouth. And human hand, there's five fingers and one wrist. Okay, we already have this type of topology. So in pose estimation task, this type of task is called as pose estimation task. And we reveal their XYZ coordinate of the element of the structure. So here, pose estimation, we define 21 joint. So these dots are indicating the locations of certain joint in hand topology. And given this RGB image, we can reconstruct their XYZ coordinate of each joint. And using deep learning architecture, we can now even reconstruct this type of 3D meshes. Okay, so 3D meshes, most of you are not very familiar with these 3D meshes, but that is having many vertices, many joint inside. So actually, this mesh is having 1,500 vertices on it. Okay, and in human body mesh, there are more than 6,000 vertices. So that's why they are visually smoothed because they are having many, many vertices. So they are appearing smooth, but if you magnify it, it is not smooth. Okay, they are having many vertices on it. Okay, anyways, in here, their task is given this RGB image, train the deep learning architecture to regress the vertice, that number of many vertices XYZ coordinate. Okay. By doing that, you can reconstruct this type of mesh reconstruction. Okay. So this is another type of important applications in computer vision domain nowadays. And also nowadays, the AI can generate images. So this is the original image given. the human face with neutral expression, but AI can be trained to generate some new image with slightly different expression. So sad person image, happy person image, and disgust expressions. Okay, you can redraw person's images into the face with new expression, and also you can also train the algorithm, deep learning algorithm, to generate some images having new attribute. So this is the young person, female, having brown hair, face images, but you can change their hair color or their gender or their ages. Okay, this is the things that you can do using the deep learning architectures. You can, if you properly train the deep learning architecture, you can achieve this. And actually, we will, in programming assignment, we will assign you with this type of applications for drawing some faces and doing some pose estimation and doing some one of these image classification or detection or segmentation tasks. Okay, you will implement by yourself. Okay, this is the collab that I introduced previously. Okay, so this is the resources, online GPU resources provided by Google. So you can connect to this web link to use the GPU, online GPU resources. Okay. Okay. So for remaining things, I will continue next Monday. Okay. So actually, after this slide, I'm explaining about this OpenCV library. This OpenCV library is open source computer vision library, and which is actually very easy to use. Okay. And I will continue for this in next lecture. Okay. So this is all for today's lecture. So thank you for attending here and see you next Monday. Thank you.